Okay, so this is the chemistry section of the Unit 1 Applied Science revision. So the first kind of questions they might ask you are all about the Earth. Okay, what I'd like you to do now is pause the video, have a go answer the questions on your sheet or on a bit of work paper that you've got, and then I'll run for the answers then on the next slide. So, structure of the Earth then, I'll zoom right in for you. You need to know that the crust is the outer bit. Then you've got the mantle, and that's made from a semi-liquid layer of magma or molten rock that has been melted and moves due to convection currents. You've got your outer core, which is very similar to the inner core, but the inner core is slightly warmer and more liquidy. What did Wegener believe? Wegener believed that all the continents were originally joined together in one supercontinent known as Pangaea. What did Wegener call that supercontinent? He called it Pangaea. What pieces of evidence did he give? He gave the evidence that, and there's 3 pieces of evidence you need to know: similar rock patterns, similar fossil patterns, and the fact that continents fit together like a jigsaw puzzle. He wasn't really believed, and people kind of left him to it, and he was kind of ignored in the science society. We now know that convection currents do cause earth plates to move a few centimetres a year, and Wegener's theory is now refined and known as plate tectonics. Okay, his theory was known as continental drift, that the continents were drifting. Okay, there's 3 types of plate boundaries you need to know about. Okay, constructive, when the plates move apart, magma rises and new land forms. Destructive, plates move together, the more dense plate goes underneath is where volcanic eruptions occur. And then conservative, when the plates slide past each other, energy builds up, causes earthquakes. Describe how the atmosphere has changed. So at the start of the atmosphere, there was lots of volcanoes which erupted, so there was loads of carbon dioxide and water. Water then cooled down. The Earth, cooled down. Water turned into oceans. Plants started to photosynthesize. Okay, thinking about photosynthesis, that's when you take in CO2 and water and make oxygen. Okay, that oxygen we then use to respire. What gas causes global warming? Carbon dioxide. What gas causes acid rain? Sulfur dioxide. This one then is a little bit of a discussion about the groups. There's no questions to fill in here. Okay, this is just knowing a couple of things about groups. There's 2 different groups you need to know about: group 1 and group 7. Group 1, boiling points get smaller down the group, melting points also get smaller, but density gets lighter. So the ones at the bottom have got a lower melting and boiling point, but they are heavier. Okay, things you need to know about group 1 elements: they're soft, shiny when first cut, very reactive, low density. Okay, they're these ones here. Group 7 then, they've got low melting and boiling point, reactivity decreases down the group. Okay, they're quite toxic, and they're non-metals. There was no questions on this is just a bit of a brief overview of the groups. Then we're looking at crude oil. Okay, so there's kind of a filling in the matching them up section here. I want you to explain what fractional distillation is, and I want you to answer these questions by here. Again, pause the video and have a go. Okay, so I've drawn my lines here. Okay, so the first section then, we had to match them up here. So subsurface mining goes here, removal of deposits of earth by drilling. Fracking, oil well is created, drilling a long hole into an oil rig. Drilling then, drilling down into the earth. Solution mining and biostock feedstock. Okay, what is crude oil? Crude oil is a mixture of hydrocarbons. How is crude oil made? Dead marine plants and animals, millions of years, intense heat and pressure. How is crude oil separated? Fractional distillation. What is cracking and why is it important? The splitting of long chain hydrocarbons into shorter, more useful. This is for supply and demand. This is used to make plastics. So cracking helps us make plastics. Okay, what are bioplastics? Bioplastics are plastics made from renewable biomass, so things like vegetable oil and fat that have been recycled and people don't use after cooking. They aren't using fossil fuels, so it doesn't cause global warming. Why should we recycle? Limits plastics in landfills. Plastic release toxic gases when burnt. Again, what I'd like you to do here, when you pause the video, split it up and just tell me what are the raw materials of the blast furnace. What kind of things can you maybe remember about electrolysis? So just pause the page, have a go, fill it in. So I've really broken down blast furnace into some really key points that I want you to remember. First off, there are 4 raw materials. It spells out Cali, if that helps anyone remember the raw materials. So you've got coke, air, limestone, and iron ore. Okay, if that helps anyone remember them. 3 of the raw materials go in at the top, and then air comes in at the bottom. First thing that happens is hot air is pumped in. O2 plus C makes CO2. That CO2 then reacts with the coke, the carbon, and makes CO, which is carbon monoxide. That carbon monoxide then reduces the iron to make iron on its own and carbon dioxide. Okay, that is all I want you to remember about the blast furnace. Moving on then to electrolysis. Not much I want you to remember about electrolysis, okay? So I want you to be thinking about panic. Okay, positive anode, negative is cathode. Okay, the positive anode then attracts negative ions, so something like Cl- is going to be attracted to the positive anode. Something like Mg2+, which is positive, is going to be attracted to the negative. That is all I want you to remember. Okay, these are ions. Okay, when they're negative, to become an atom, they don't have a charge. So that's an ion, is something with a charge. An atom then is something without a charge. To become without a charge, you need to lose or gain electrons. Okay. The only other final thing worth mentioning over here with iron is to know that slag, which is the impurities, comes out by here, and then molten iron comes up by here. So that's the other thing worth mentioning. Next kind of thing then, pH, naming some acids and bases, looking at the pH scale. Again, pause the screen, do what you can, and then I'll be back in a minute to fill in the blanks. So I'm not going to read through all of these because I'll be here forever, but I am just going to zoom in, again, pause the screen. A couple of things to help you at the top. Chlorides are made from hydrochloric acid, sulfates are made from sulfuric acid, nitrates are made from nitric acid, okay? If something ends in carbonate, that makes H2O plus CO2, okay? These all ended in either hydroxide or oxide, which meant they were water, okay? But if something ended in carbonate, there'd be another column at the end to put plus water. Again, just pause the screen and check you've got them right. So moving on to what an acid is, I put a little picture of the pH scale, so you need to know the colours, okay? You can remember it with a little rhyme, like Richard of York gave battle in vain. They sometimes use purple instead of violet, that's where that goes in. What is an acid? Below 7, H plus ions. What is a base? Above 7, OH minus ions. What is an alkali? It's a soluble base. What is the pH scale? The measure of how acidic or basic something is. What is an indicator? Used to identify if something is acidic or basic. What is the equation for neutralization? And sometimes you might see it like that. Acid plus a base gives water. Okay? So acid plus a base makes salt plus water. Again, quite a lot of information to fill in. So I want you on up here to identify whether something's an element, a compound, or a mixture. By here, I want you to label the atom and fill in the table. Electronic structure. By here, of them 6 elements, and then protons, neutrons, and electrons. Okay? Again, pause the screen, and I'll be back in a minute to give you a good go. So moving on then, looking at this, next little bit then. So that's a compound. This is a mixture of elements. This is a mixture, one element, one compound. These are compounds, these are elements. These are elements, this is a mixture. These are elements, and this is a compound. Okay. Then, these are electrons, and they orbit in the shells. This is the shells, so the lines are the shells. Your nucleus is the bit in the middle, and it contains your neutrons and your protons. Okay, I just realised I made a spelling mistake there. So, protons then, I've got a relative mass of 1, and their charge is +1. Neutrons then, relative mass of 1, charge is 0. Electrons, 1/2000, and their charge is negative. Over here then, okay, big things to remember, and there's lots of information on your sheet to help you. This is the mass number, atomic number, mass number, okay? Mass number tells you number of protons plus neutrons. This tells you number of protons, okay? Protons always equals electrons. So if it's got 2 protons, it's going to have 2 electrons, okay? And then 2 neutrons, because that's 4 minus 2. Okay, same here, 40 minus 20 to give us the neutrons. This one then is 56 minus 26 to give us the neutrons. This is 20 minus 10 to give us the neutrons. This is 27 minus 13 to give us the neutrons. Remember, it's easy to do the protons because it's just the number there. And then this one is 12 minus 6 to give us the neutrons. So protons is always the smallest number, and then neutrons is the mass number, take away the atomic number. Okay. This one then, I looked up on the periodic table, it's got 11 electrons. Okay, so Na 11, 20, 23. Okay, so 11 is the smallest number, that's the one you're looking for. 2 go in the first shell, 8 in the second shell, 1 in the outer shell to add up to 11. That means it's in group 1, because it's got 1 in the outer shell, period 3, because I've used 3 shells. Same kind of thing then for argon. Atomic number 18, so 2 go in the first shell, 8 go in the second shell, 8 go in the next shell. Group 8, period 3. Aluminium then, 2 go in the first shell, 8 go in the second shell, that adds up to 10. You've got 13, so 3 left. So group 3, period 3. Silicon then, 16, so 2 go in the first shell, 8 go in the second shell, 6 go in the next shell, so group 6, period 3. Magnesium then, 2, 8, 2. Group 2, period 3, and then carbon, atomic number of 6, 2 go in the first shell, 4 go in the next shell, so that's group 4, period 2. Last little bit then is all about water. Again, pause the screen, and then I'll be back in a minute to kind of talk through it. So what is an ion? And I've kind of talked about this throughout the video. An ion is an atom with a positive or negative charge which has lost or gained an electron. What is an isotope? An isotope has the same atomic number but a different mass number. So these two are isotopes of each other because they've got the same atomic number but a different mass number. What is in our water? Microorganisms, iron, bacteria, dirt. How can we save water? Shower instead of bath, turn off the water to brush our teeth. This is how we kind of separate out water, and this is the process of cleaning our water. So we collect it, then sedimentation is the removal of large particles, filtration is the removal of small particles, disinfection is adding chlorine to kill all the bacteria, and then we store it for commercial or domestic use. Okay. Water is often classified as hard or soft. Soft water readily forms a lava with soap. Hard water, which does not readily form a lava with soap, is called scum. Hard water is caused by the presence of calcium and magnesium ions. Soft water has a very low concentration of calcium or magnesium ions. The type of rock that water flows over determines how the water will be, whether hard or soft. Some then advantages of hard water include it's the taste, and it's good for your bones and your heart because it contains calcium 2+ ions. Okay. Disadvantages include forming a scum, cause limescale, blocked pipes. You can remove hardness by boiling or ion exchange.